Imagine standing beneath a vast star-studded sky, where one fiery beacon stands out, glowing with an intense red hue that seems to pulse like a cosmic heartbeat. This is Betelgeuse, a red supergiant star that has captivated humanity for centuries, not just for its beauty, but for the profound mysteries it holds. This colossal star, located over 640 light-years away in the constellation Orion, is no ordinary celestial body. It is a titan of the cosmos, so immense that our Sun, a respectable star in its own right, appears like a mere speck in comparison. If Betelgeuse were placed at the center of our solar system, its outer edges would swallow Mercury, Venus, Earth, and possibly even Mars, stretching nearly to the orbit of Jupiter. This staggering scale challenges our imagination, reminding us how small we are in the grand tapestry of the universe. Betelgeuse is not just massive, it is dynamic, alive with activity that defies the serene appearance of the night sky. Stars, from our distant vantage point, seem like quiet, eternal pinpricks of light, but they are anything but still. Betelgeuse, in particular, is a pulsating red supergiant, a star that breathes in cycles, expanding and contracting as if inhaling and exhaling the very essence of the cosmos. These pulsations cause its brightness to vary dramatically, shifting from a faint glow to a radiant beacon visible to the naked eye. This variability has earned it a place among the most intriguing objects in the sky, a stellar giant that demands our attention and curiosity. The universe itself is a story of expansion, a fact uncovered in 1929 when scientists realized that galaxies are racing away from each other, stretching the fabric of space-time. By 1957, we learned that the elements composing our bodies, carbon, oxygen, iron, were forged in the fiery cores of stars like Betelgeuse. These discoveries reshaped our understanding, revealing that the cosmos is not just a backdrop, but a dynamic, powerful force that shapes everything, including us. Betelgeuse, with its immense size and restless behavior, embodies this cosmic power, serving as a window into the processes that govern the lives and deaths of stars. Yet, for all its grandeur, Betelgeuse is a star in turmoil. Recent observations have revealed signs of instability, a trembling that suggests something profound is happening within its massive structure. This is not the quiet, predictable star we might imagine. It is a cosmic giant nearing the end of its life, caught in a delicate dance between creation and destruction. To understand Betelgeuse is to peer into the heart of the universe, to grapple with questions about why we exist, why stars and planets form, and what destinies await the countless worlds scattered across the cosmos. Let's paint a picture of Betelgeuse's scale to truly grasp its magnificence. If Earth were a tiny pebble, the Sun would be a basketball. In this analogy, Betelgeuse would be a stadium, dwarfing everything around it. Its surface, glowing at a relatively cool 3,500 Kelvin compared to the Sun's 5,500 Kelvin, gives it that striking red hue, a color that speaks of its advanced age and immense size. Despite its lower temperature, Betelgeuse's sheer scale means it radiates an extraordinary amount of energy, though less per unit area than our Sun. This balance between size and luminosity makes it a fascinating subject for astronomers, who watch its every flicker for clues about its inner workings. The pulsations of Betelgeuse are like the rhythmic beating of a cosmic drum. These cycles, ranging from short bursts lasting around 185 days to longer ones spanning over 2,035 days, are driven by the star's expansion and contraction. When Betelgeuse expands, its surface cools and dims, spreading its energy across a larger area. When it contracts, the surface heats up, concentrating its energy and glowing brighter. These changes are not random. They follow patterns that astronomers have tracked for decades, using tools like photometry, which measures the star's light output, and spectroscopy, which dissects that light to reveal details about its temperature, motion, and composition. Photometry is like taking the pulse of Betelgeuse, capturing how its brightness fluctuates over time. Spectroscopy, on the other hand, is like reading its diary, uncovering the chemical and physical processes hidden beneath its fiery surface. Together, these methods paint a vivid picture of a star in constant motion, its outer layers swelling and shrinking in response to the forces at play within. In early 2021, astronomers noted an unusually low brightness, a moment when Betelgeuse seemed to dim dramatically, sparking speculation about its fate. Was this a sign of an impending supernova, or merely a temporary dip caused by dust clouds or internal convulsions? The answer remains elusive, but it underscores the star's unpredictable nature. At the heart of Betelgeuse's instability lies its ongoing battle with its own fuel supply. Stars like Betelgeuse shine by fusing hydrogen into helium in their cores, a process that releases the energy we see as light. But Betelgeuse, as a red supergiant, has exhausted much of its hydrogen. Now, it is burning helium, fusing it into heavier elements like carbon and oxygen. This process is less stable than hydrogen fusion, leading to bursts of energy that ripple through the star, causing its outer layers to expand and contract. These pulsations are not just cosmetic, they are signs of a star in transition, one that is shedding its outer layers through powerful stellar winds. These stellar winds are like the breath of a cosmic giant, expelling vast amounts of material into space. This mass loss reshapes Betelgeuse, altering its structure and influencing its evolution. As the star loses mass, its outer layers become less dense, allowing them to expand further, only to contract again under the pull of gravity. This constant tug of war between gravity pulling inward and radiation pressure pushing outward creates the pulsations we observe, each one a clue to the star's internal dynamics. To delve deeper into these processes, astronomers turn to powerful computer models, virtual laboratories that simulate the complex physics of a star like Betelgeuse. These models account for everything from nuclear reactions in the core to the fluid dynamics of its outer layers. They allow scientists to predict how Betelgeuse's pulsations might evolve, connecting the dots between observed brightness changes and the star's internal conditions. It's a bit like solving a cosmic puzzle, piecing together clues from light, motion, and energy to understand a star that is millions of times larger than Earth. One of the most fascinating processes within Betelgeuse is stellar convection, the movement of energy from its core to its surface. Imagine a pot of boiling water, with hot bubbles rising and cooler water sinking. In Betelgeuse, hot plasma from the core rises toward the surface, carrying energy that makes the star glow brighter. As cooler material sinks back toward the core, the cycle repeats, creating convection currents that drive the star's pulsations. These currents are responsible for the rhythmic changes in brightness we see as energy surges to the surface and then recedes, like waves on a cosmic ocean. This convection is not just a mechanical process, it's a window into the star's soul. The energy flowing through Betelgeuse shapes its appearance, making it brighter when hot material reaches the surface and dimmer when cooler material dominates. These fluctuations are not random, but follow patterns that astronomers classify as characteristic of variable stars, stars whose brightness changes over time due to internal or external processes. Betelgeuse's variability is particularly striking, as its massive size amplifies these changes, making them visible even to amateur stargazers. The interplay of forces within Betelgeuse, gravity pulling inward, radiation pressure pushing outward, creates a delicate balance. When the star expands, its surface cools, dimming its light. When it contracts, the surface heats up, glowing brighter. This cycle, driven by the complex interplay of nuclear fusion, convection, and stellar winds, is a testament to the dynamic nature of stars. Betelgeuse is not a static object but a living, breathing entity, its every pulsation a sign of the cosmic forces at work. As Betelgeuse nears the end of its life, these processes become more intense. The star is running out of fuel, and with each passing cycle, it grows less stable. The helium burning in its core will eventually give way to the fusion of heavier elements, a process that will lead to the formation of a dense core surrounded by layers of burning material. This is the prelude to a supernova, a cataclysmic explosion that will mark the end of Betelgeuse's life. When that moment comes, it will outshine entire galaxies, briefly becoming one of the brightest objects in our sky. But when will this happen? The answer is one of the great uncertainties of astronomy. Betelgeuse could go supernova tomorrow, or it could take thousands, even millions of years. Its recent instability, those trembling pulsations and dramatic dimming events, has fueled speculation, but the star keeps its secrets well. What we do know is that when Betelgeuse explodes, it will leave behind a legacy of heavy elements, the building blocks of new stars, planets, and perhaps even life. The carbon and oxygen in our bodies, forged in the cores of ancient stars, are a testament to this cosmic cycle. The study of Betelgeuse is not just about one star, it's about understanding the universe itself. Every pulse, every change in brightness is a clue to the processes that shape the cosmos. Astronomers use a variety of tools to unlock these mysteries, from telescopes that capture light from across the electromagnetic spectrum to computer models that simulate the star's inner workings. These efforts reveal not just the mechanics of Betelgeuse, but the story of all stars, from their birth in clouds of gas and dust to their dramatic deaths in explosions that seed the universe with new possibilities. Betelgeuse also reminds us of our place in the cosmos. Its immense distance, over 640 light-years, means that the light we see today left the star long before humans built pyramids or wrote poetry. Traveling at the speed of light, it would take us over 640 years to reach Betelgeuse, a journey far beyond our current capabilities. If we relied on today's technology, the trip would take over 12 million years, longer than the entire history of our species. This vast scale humbles us, yet it also inspires us to keep exploring, to keep asking why the universe is the way it is. The red glow of Betelgeuse is a beacon, calling us to look up and wonder. It challenges us to think beyond our daily lives, to consider the forces that shape galaxies, stars, and planets. It reminds us that the universe is not a static painting, but a dynamic, ever-changing story, one in which we are both spectators and participants. As we watch Betelgeuse pulse and tremble, we are witnessing the final chapters of a star's life, a drama that has unfolded over millions of years and will continue to captivate us for generations to come. What makes Betelgeuse so compelling is its unpredictability. Its brightness varies in ways that defy simple explanation, its pulsations hinting at processes we are only beginning to understand. Each observation brings us closer to unraveling its mysteries, yet each new discovery raises more questions. Why does Betelgeuse pulse the way it does? What will its final moments look like? And what will its supernova tell us about the universe's past and future? As we continue to study Betelgeuse, we are reminded of the power of curiosity. The same impulse that drives us to look up at the night sky drives us to build telescopes, write equations, and dream of distant worlds. Betelgeuse is more than a star. It is a symbol of our quest to understand the cosmos, to find meaning in the vastness of space. So, the next time you gaze at Orion and see that red glow, take a moment to marvel at Betelgeuse, not just for its beauty, but for the story it tells, a story of creation, destruction, and the endless dance of the stars.